Hi there, welcome back. Today we've got something unusual. We've got a naked amplifier to do some repairs on. And I didn't strip it. The owner brought it in already stripped. I believe he tried to do some repairs on it. And the result was not only did it stop working, but it actually smoked quite a bit. Now it's a Marantz 250M power amplifier. He also brought in the preamp, which also had a few issues with it, but nothing interesting enough to do a video on. I hope that this turns out to be. So let's have a look at it a little bit closer and see how we go from here. Now there's not much on this amp. At the back all you've got is the two inputs, the speaker outputs left and right. There's a fuse, there's the power inlet, and then there's a power outlet to power auxiliary devices. Now the interesting stuff is actually on the inside. This thing is pretty old school in terms of how it's built. They've got the power transformer in the middle there, very, very beefy, with the rectifiers and the filter capacitors immediately to the left. These things are almost homemade look to it. There's the relay board and output protection, speaker protection board at the back there. And if you look on further, a lot of sort of point-to-point wiring, and then you've got your right channel tied to the right heatsink, which you see there. All the respective wires coming in. It'll be the power supply and speaker outputs. On the left is the other channel on the left heatsink, very similar to the first one. There we have the 4 output transistors mounted to the outside of the heatsink. And on the other side, we start seeing the problems. 2 of them completely blown out. Now, fortunately, the 2 channels on the heat sinks are quite easy to separate. And that's exactly what we're going to do here. All you need to do is to remove, I think it's about 6 screws that hold the heat sink to the chassis. And you actually remove the entire heat sink with the power amp channel on it. Now, on first inspection of the board, it doesn't really look too bad, but looks can be deceiving. We start seeing a few strange things when you get closer. For example, the little transistors, the 292 transistors, are actually fitted in the wrong way, which means they've been replaced, which means the pinout of the ones they've used here are not the same as the original. That thing's been removed, the inductor's been removed and unwound somewhat. There's a Vimmer cap. Some of those film caps are actually pretty good, but they're mounted in sort of pretty roughly. It's a bit strange. I think it looks like someone's done a really extensive rebuild job on this, and I think we'll find a few shortcomings. To remove the board from the heatsink, there are actually supposed to be 4 screws. And it looks like there are only 2 in there. It's always a bad sign, it means someone's done a bit of a hack job and hasn't been careful mounting everything back the way it's supposed to be. These 2 are actually the connectors for the collectors of the power transistors. They were both in there. So at least that hasn't gone too far wrong. But we definitely have to see about the others. Now, to remove the board, you actually unclip it from the legs of the TO2's transistors, from the power transistors. There are pins on there, and they come out. And then we have to remove the connector to a, it looks like a, what is that? It's a limiting resistor of sorts. And then, of course, there's the transistor, one transistor that's connected to the heatsink, which is in part of the bias circuit that's just plugged in. The reason for that is so that temperature compensation works itself into the heating of that transistor itself. So that's okay. Move everything aside, and we're left with just the board and a few wires connected to it. Should be quite easy to work on. And we can get a good look at the underside of the board as well. See what's happened here. I'm almost afraid to look closer. Now, other than some pretty old solder joints on this part of the board, don't see too much, and on the right hand corner there you start seeing a bit of a hack job. But let's look at this side first. Look at that. Somebody removed or cut tracks for a previous mod and then tried to put them back. And some of the pads have actually come off there. So we'll have to do something about that. That looks bloody awful. And, yep, yeah, that's actually been a little bit more than just a little mod. I think there's been some serious burnout on that board previously, and they tried to remake those pads. So there's quite a bit of work cut out for us here. I really think I'm going to have to check this thing component by component, connection by connection. And of course you can't trust the connections because they've been cut. Now, before desoldering anything, I usually take quite a few photographs of any wires coming onto the board so I don't have any doubts later on. And you can see that clearly there, the audio input, the power supply, the connector for the bias transistors, everything properly documented, and we can finally have the board free and clear so we can inspect it a bit closer. Now, I didn't go too much into what was wrong with this before, but I did mention that it had smoked quite a bit. When I got it, I actually tried to power it up, but the current draw from the dim bulb limiter was so high that this thing was drawing the voltage down to less than half of the main supply. So something was obviously wrong. And what I did then is I separated the right channel from the power supply, and I still had the same problem. I separated the left channel, I still had the same problem, which meant that I was more or less forced to look at this from the start up. Fortunately, I have the schematic and the service manual for this. So I took this channel and I literally started from the beginning and went component by component. I realized that with very few exceptions, every single, or practically every single component had been swapped out. So somebody thought of doing a rebuild on this. And other than pretty untidy component layout, it proved to be more or less okay with a few notable exceptions. We had a capacitor here that was reversed. Now, fortunately, they used some pretty good capacitors. They used Seraphim electrolytics. This thing was put in the wrong way. Fortunately, under normal conditions, the voltage at this point is literally close to zero. And that one is supposed to be close to zero as well. So the actual voltage, DC voltage across that capacitor would have been minimal. So it didn't damage it, but it was the wrong way around. Some of the solder joints on here were very, very iffy. So those were all checked. The zero offset pot here was just fine. That one was fine. And let's see what else. We did have this resistor here was the wrong value. It's supposed to be 220 ohms. It was completely the wrong value. Can't remember exactly what it was now. That capacitor there was also swapped out because it was iffy as well in terms of ESR. All these transistors have been swapped out and they are now different values to the ones that are specified on here. And I understand that Marantz have some components, especially transistors, that are very difficult to find now. So I decided to leave well enough alone and not swap them out unless they were defective. So everything was checked, and as I said, these transistors were actually a different pin layout, the opposite pin layout to the original ones. The original ones would have been CBEs, collector base emitter in a row. These were emitter base collector in a row. So all you do is you have to put them in the wrong way around. That's why they look a bit funny, that middle leg coming forward as opposed to going back, which you'd normally see. And then going on through, we got to this section here with the, this is the bias section. So you've got your bias adjust pot. That thing was completely open the wiper was completely open, and although the resistance from the two opposite legs were fine, about 115 I think it was, 110, so that was fine in terms of value, but the wiper wasn't making contact, so I had to actually dismantle it. It's a very good quality pot. It's a nice sized pot, so I didn't want to really mess with it. You know, I didn't want to replace it. So I actually dismantled it. It came apart quite well, and I found some debris inside, not only the usual dirt, but actually some, well, pieces of dirt, which obviously had made the wiper lose contact with the wire wound element, and it is a wire wound. So it's a 2-watt pot, so I had to do a full cleanup and then tested it, and it works fine. That transistor there is the one that's on the heatsink, and you've got the green, the blue, and the yellow wires to take it to there. There's also a transistor here which was actually showing just as one diode, so this transistor had gone. MPS 6519. And after some extensive searching on the web, I discovered you could actually replace that with a BC557, which is also the same pinout as this original one. So that was replaced. And then we got to the stage where all the messing around with the tracks had happened. And what I decided to do there is use this copper tape and remake the tracks, and then solder them on, and then use a solder wick to get the excess solder out. And then you can go to town. You can actually paint over it and make it look more original, or exactly like the original. So you don't see those, the solder, the silvery tracks. You just see the solder mask versions. And unless you look closely, they actually look pretty good. It actually does a pretty good camouflage job. So again, going on, all that was repaired and all the connections and components checked from those points. You can't take anything for granted because you just don't know if they've put it together the way it should be. And that took us then to the end, and now it left us with that, I'd removed that inductor. I rewound it and put it in the way it should be. It was missing a turn, the way they sort of unwound it to try and get it into the space. And so that was completed. Now, I haven't actually tested this yet, so I'm a bit wary about whether I've found all the possible faults and whether I haven't created any new ones, which is always a concern. You just never know when you might do more damage than good. I've been very, very careful with this, and I think I'll be ready to test it now. I will be testing this as a single channel only. I'll disconnect the other side. I'll be using the dim bulb limiter on maximum limit. And hopefully we've got a working channel, and then we can start with the other one. Let me show you the board. I'm actually quite proud of the result. All the pads, all the soldering has been redone. And you can actually see where the repairs were done here. Now, with the shine on it, it doesn't look so good. But if you look at it like that, from a little bit of a distance, the pads have been camouflaged with some green paint that sort of approximates the color of the solder mask on the tracks. And the idea is that you don't see it. And I've just realized, and this is an opportunity to show you, you see that there? That's what that would look like without the paint. I forgot to paint that one. So you see, you can forget things. That's been redone as well. So I can just repaint that one and get it all complete. Coming up here, that mess over there that you saw previously was it's sort of a riveted solder tag on there, and that had broken off contact from the pads. Same with those two, and they'd put a wire on. Now what I decided to do was, because this is hollow in the middle, I decided to put some pieces of wire down and solder it properly, and the result is you can then paint over it and hide some of the mess. So that looks pretty good. This thing looks pretty good, with the exception of that piece that I forgot. On the other side, all the components, a lot of the components, all the transistors were removed, and they've now been put in. You can see it, you know, a little bit more neatly, vertically, so they don't sort of lie on their backs. Some wiring has been, you know, straightened out. The little orange caps, those are 47 picofarad. Those are low value capacitors. They were all sort of hanging up in the air, very high off the board. So they were soldered closer to the board. You've got low capacitance, and you then, you know, you've got to take in consideration the lead length. You don't need to leave them hanging up in the air. Those film caps were all straightened and soldered properly. Those two there, you can see it's all nice and neat. Same with that one there. That one you have to be careful so it doesn't touch the heat sink. So I'll put a couple of heat shrink on the legs to avoid any shorts. This is another one that was all skewy and now it's straight. Some of the resistors were straightened out. Those pots, those little pots, those are current limits for the output. They've been cleaned out and resoldered in. You can see the inductor. It's been more tightly wound, and the position where they go into the board is now, I think, the original position. There were two resistors here that, you see those sort of, what is that color? Teal? Those are 0.1 ohm resistor, 5 watts. Those are actually the emitter resistors, or rather the collector resistors. What is it? Collector to output. So those are where you would actually measure your bias current across. Those were both, the one was in there already that I'd put in because the other one had blown out, and I replaced that one as well. So everything is sort of nice and neat and cleaned up and working. You know, the diodes are fine. The transistors were checked out of circuit. Every transistor was tested out of circuit to make sure that they're working, because they are different transistors to what the original one had on here. So I tested every single one of them. And I think this thing is ready now to go back in. And the way it goes back in is you have to sort of fit it. You have to fit it to the pins on the transistors that you have there. Now, we've only got 2 transistors. Fortunately, the ones that blew, the top one and that one, were a complementary pair, and they basically were in parallel with the other one. So this is 2 PNPs, or is it NPN? I think these are 2 PNPs, that's 2 NPNs. They're in parallel, they're doing exactly the same job except doubling up the power capabilities, the current capabilities. So we can actually test this with one each, and that pair, which is a complementary pair, seems to be okay. These are replacements. These are MJ, what is that? MJ15004G and MJ15003Gs. They are available. I'll be ordering them when I know exactly how many I need. Okay, so I think we're ready to test this. I'll just, put it on here. You have to do it very carefully so that you match, so you basically put the pins in the right place, and we're ready to go. Connect it up properly, make sure there's no shorts, and it's in. And now, of course, we have to make sure we get all the screws in, get this thing safe and tightened down, and get it ready for some testing. All right, I think we're ready to test this thing. What I've done here is I've disconnected the left channel, that guy there. These are the 2 wires. Disconnected them from the power supply. I only want to have that channel active. So whatever mishaps have happened on that channel, it's not going to affect our current draw too much, and we won't hopefully not see smoke coming out of there while we're trying to do some tests on this side. Now I have the amplifier connected to the dim bulb tester. It's on safety mode, so there's isolation transformer, no mains ground. It is currently on limit, one lamp on, all the others are off, so there's only a 40-watt bulb in series there. That is the maximum current restriction you can get. So if there's anything wrong, we should have a fairly low current coming out of there. What else do we have? We have a 1 kilohertz sine wave coming in here. Fairly low amplitude. I'm going to give it 20 millivolts RMS. It's not on at the moment. It's actually off at the moment. I have the power supply connections, the negative, the positive, and the ground connected to the unit. I have an 8 ohm dummy load connected to the unit. That's a 50 watt resistor. So if we power it on, this thing should go on. We won't hear anything because we've got the dummy load. Okay, so what are we going to monitor? Well, on Big Brother, we're actually going to monitor the current, the idle current, through the two, in this case, two output transistors. There's only one complementary pair. Remember, you should have two. Now, what they tell you to do is to reduce or drop the idle current to the minimum. And the minimum is achieved with the pot as far counterclockwise as it'll go. We're actually measuring the voltage across two 0.1 ohm resistors, which are the resistors that connect the transistors collector to the output. So we're doing two in series, so we're getting the voltage drop across both of those resistors, and they tell us to look for 15 millivolts. Well, 12 to 15 millivolts. Well, because we've only got one pair, they're not doubled up, we don't want to go above 6 millivolts, which is half of 12 for two transistors. If it's four transistors, because they're all feeding through those resistors, you should double up. So we want about 6 millivolts maximum. And we're also going to measure the output offset. And the output offset, let's find a ground point here. There's ground. And there's the output, and that's on DC volts, that's on DC millivolts. Now, what should we see? We have got no input. We should see that light glowing fairly brightly and then going slightly dimmer, hopefully. We should see that less than 6 millivolts. We should see that as close to 0 as possible. I don't know how much current the rest of this amp is drawing, so I don't know how much of that current you're going to see there is actually going to the rest of the circuit and how much is coming to this part of the circuit. Just check everything again. Looks good. And let's hit it. Okay. That relay protection board is actually working because I've just heard it click. I think it comes off another secondary from here. I've got 1.2 millivolts. I've got damn close to 0 on there, which is good. Now let me try and zero it and see what happens. Now, see if this works. Yep, that's working. That's the offset. Let's leave it at that. That is the idle current, but that means nothing because I've got the voltage. That one bulb is dropping the input voltage to 178 volts, so it's fairly low. But let's see what happens to that if I adjust this. Yeah, it is working. Let's leave it low. I'm just going to switch on, let's see the scope. I'm going to switch on the output and see if we get anything. Yes, we are. We are getting a signal there. That's only 20 millivolts going in. So it's fairly low. So let me see if I can get this all in now. Really trying to get everything in here. We can see, oh, that's a bit high. Bloody hell, that is far too high. Oh no, that's too high because I've got an output on. Okay, oof, that was a fright. Okay, what I'm going to do is, without the output on, so nothing on the scope, I'm going to give it a bit more juice here and see what happens. It's still stable. It's now seeing 200 volts. Let me give it another lamp. It's now seeing 215 volts. That's looking pretty good. It's looking stable. Let me give it the output signal, input signal again. Now, let me just switch off the signal for a second. We're seeing 1.6, which is very low bias current. Now, I can give it more, but I won't give it too much. I could go as high as 6 millivolts, but I'm sticking to 3, just for now. Let it stabilize. That just means that I'm biasing the transistors pretty cold. I intend to leave it pretty cold for a while until I've actually got the other pair in, and then I will do the proper bias adjustments. Our output offset, DC offset, is at 19 millivolts, 20 millivolts. I can adjust that. That's not bad actually. They say plus minus 50 millivolts. Okay, I'm going to drop that just a bit. Let's leave it at that. Leave it low. All it means is that we might get a little bit of crossover distortion. And that thing is at 214 volts going into the amp. 240 milliamps it's drawing. There is no signal. When I give it a signal, that should start drawing more current. It's not drawing much because the signal is only 20 millivolts. But now, I think we're good. I think we're good. Let me show you what that signal looks like. Everything looks stable. I'm just keeping an eye on things. I'm upping the input volume level, input signal level from 20 millivolts RMS to 30, to 40, to 50, 60. That's now 2.4 volts. Going up, it's now 100 millivolts. I have got 4 volts RMS there. The current draw from the dim bulb is now 270 milliamps. If I keep going up, those light bulbs are starting to glow, which is normal. And I've got 6 volts. I'm going to give it one more light bulb. And I'm going to keep putting this up. That is 200 millivolts coming in, 7.5 over there. Everything seems to be okay. Which means this was a successful test, which is pretty good. It's now at 7.5 volts RMS over there, which in terms of power isn't too much. It's, what is it, 4950, about 6 watts, 7 watts, which isn't much. But the important thing is that the DC offset staying stable. And I don't want to give it that much power because I've only got 2 transistors on here. I know I could go a lot higher, but for now, this is the test that I wanted to do, and I believe we've got a successful repair on this one. It'll obviously require those 2 extra transistors, and when I get those transistors, they'll be put in there, and this thing will then be tested completely with again setting the bias current properly to between over there 12 to 15 millivolts. We'll be able to test it without the dim bulb. We'll put this thing on full. Again, this thing will come up slowly. I'll leave this for a little bit longer like this, just producing 7.5 volts into 8 ohms. Just leave it a little bit longer. See if anything feels uncomfortable on here. It seems to be fine. The DC offset, the output offset is working. The bias select is working. I've got 19 millivolts, 20 millivolts offset. And obviously this thing, you leave it for a while, let it warm up, and it'll only do that when it's got the proper 2 pairs of transistors. And then obviously we would set everything before doing the final tests. So yeah, I'm happy to report that that reconstruction, if you want to call it that, has worked. It seems to be fine. I'm always a little bit, well, incredulous when these things work first time. But hey, I'm not complaining. Anyway, that's the first channel done, or nearly, and then I'll come back to you when I start the other channel, and hopefully we'll be able to put this baby back to full working order. I hope you've enjoyed that. I hope you've learned something. I certainly have. If you like that, share, subscribe, and all that jazz. And if you want to support the channel, do so on Patreon. See you back soon. Bye for now.